Okay, so welcome back to another video. Today we have what seems to be a simple, algebra problem expression we want to solve for. I forgot to write the word all, but we want to solve for all x in the real such that 64 to the power x is equal to x to the power 192. So you can probably guess from at first glance when solving something that has, the variable as an exponent, we would need to do some sort of, logarithmic algebra, hybrid solving technique, which in that regards, you are correct. We are going for that approach. But a lot of people would usually think that once you would find that one answer and that's it. But there's actually more to it beyond that. So there's actually more than one solution. Basically, as you're reading from this title, there's more than one solution to this algebraic expression over here. A special function is actually going to be used to actually solve for the rest of the solutions rather than the first one that we're actually going to find the easiest solution, you could say. So something to look forward to. It's going to be an interesting, ride to actually go through the details of all this. So why don't we actually just jump right in? So as you can guess from over here, we're actually going to take the natural log of both sides. So that means I have x, of course, the exponent is going to be the front. So multiply with the natural log of 64, and then set this equal to 192 multiplied by the natural log of, and to preserve, the definition of the natural log itself because it's a positive function, I'll just write this as the absolute value of x over here. Okay. So now, of course, as you can guess, when you're solving for, some variable on its own, we want it by itself. So what I'll do is, of course, divide the 192 to both sides and divide the x to both sides. So we have the natural log of 64, then divided by 192, set this equal to the natural log of x, so in that absolute value, and then divided by x. Okay, let's get a little creative with this left-hand side over here. What I can do is 64 is the same thing written as 2 to the power 6. So I'll actually, rewrite that and then take that exponent outside. So we have 6 times the natural log of 2 and then divided by 192. So of course, that's still going to be the natural log absolute value of x and then x at the bottom. So continuing on forward, that the natural log of 2 or 6 divided by 192 is going to be just 32 on the denominator. So I have the natural log of 2 divided by 32. So that's still natural log of x and then divided by x. So let's get a little creative here. Let's now multiply an 8 to both the numerator and denominator. So I have 8 times the natural log of 2, and then so 8 times 32, which is the same thing as, actually, let me first write this out in full. So 8 times 32, and then we have the natural log of x and then divided by x. So of course that can be rewritten as the same thing as the natural log of 2 to the power 8. And then on the bottom we have is going to be, so 8 times 32 is going to be 256, which is then equal to still the left-hand side or the right-hand side. And then notice that 2 to the power 8 is going to be the same thing as 256. So the natural log of 256 divided by 256 is equal to the natural log of x and then divided by x. Now you actually just compare the left-hand side and the right-hand side. We have that the numbers match up and that our first solution we have is that x is going to be 256. So I'm just going to box this. So that is actually our first solution. So keep in mind, we want to solve for all the reals. There's more to this than you think. So how do we actually approach the other solutions, you could say? Well, let's actually consider that if we're dealing with negative and positive functions. So first, let's deal with the negative numbers. So let me first write, consider x being less than 0. But wait a minute, we have a natural log function. It's supposed to be a positive function. So, but not to fret, because we can actually just rewrite the inside of our natural log argument as the natural log of negative x. So we actually just go back to starting with what we have specifically for natural log of 2 divided by 32 from that left-hand side. So we considered that. So the natural log of 2 divided by 32. So we set this equal to the natural log of negative x and then divided by x. Okay, so let's do a little bit of some rearranging such that I'm actually going to write this in terms of like a exponent form rather than a fraction form. So this will yield us with x to the -1 and then times the natural log of negative x, of course still being the natural log of 2 divided by 32. Okay, And next thing we're going to do is let's actually just multiply a negative to both sides of the equation. So negative x to the power negative 1 ln of negative x. Then set this equal to the negative natural log of 2 divided by 32. Okay, and then the next step we're going to do is we're actually going to convert this such that it's going to be the base of the form e. So rewriting this expression, so that also includes the negative over here, we're going to get e then to the, negative ln of negative x, and then multiply with ln of negative x. So of course, negative ln of 2 divided by 32. Okay, and then what I'll do now is let's actually just divide this negative 1 to both sides. So that means the negative is going to be associated with the natural log function. So e negative ln of negative x, then multiply with negative x, or rather negative ln of negative x. And of course, it's going to be positive natural log of 2 and then divided by 32. So how do you approach something like this? Well, the special function we'll be using is what's known as the Lambert W function, aka it's a product log function, the omega function. It's a multi-value function that's actually rightly considered like as the branches of a converse relation to the function specifically f of w, which is equal to w times e to the w, where w is some complex number, any complex number really, and then e of w is, an exponential function. So we'll be using that. It's actually in that nice form. So if you actually plugged in, the right inputs correctly by taking that Lambert W function, we're gonna have that. So let me write take Lambert W. All right, and so I'm actually gonna keep in this color. Once we get further, I'll actually switch eventually. So taking the Lambert W function, you plug in the right inputs, find the right inputs rather. We have that the negative ln of negative x is going to equal to the Lambert W of ln of 2 and then divided by 32. Okay, and then so we just divide the negative to both sides, so you're left with ln of negative x equal to the negative of this value, and then just take the e base of that and then divide it by the negative, and then we have another solution solved that x is equal to negative e to the power negative w, Lambert function w, of ln of 2 divided by 32. Okay, so that is yet another solution we have solved for. But there's still some left to go because we only considered the negative functions or negative values. So let's consider the positive values. So next thing is, well, I guess you could say this is rather the last thing. I would use this color over here. Let's use this one. So let's now consider x being strictly greater than 0. The same logic applies to just like what we were doing earlier. So I have natural log of 2 divided by 32 equals, so I can actually just keep this as natural log of x divided by x. Okay, so same logic follows. So we solve, rewrite the expression a little bit. So x to the negative 1 and then ln of x equals ln of 2 divided by 32. And then if you do all the same thing over again, we're going to have that the following can be written as e to the negative ln of x, and then now multiply with negative ln of x, and also because that we want it in that same form, so I had to multiply negative to both sides. So then it's equal to negative ln of 2 divided by 32. Then we just take that Lambert W function yet again. So so I have the natural log of x is then equal to w of negative ln of 2 divided by 32. And then if you just solve for x by itself, then x is therefore just equal to e to the power negative w of negative ln of 2 and then divided by 32. Okay, so there we have it. We consider for all the positive reals, so positive and negative, we actually solve for the simplest case over here. So this actually leaves us with 3 solutions we have solved for that satisfies our given. We have found that x is equal to 256. We have that x equal e to the negative e to the power negative the Lambert function w, Lambert W function of ln of 2 divided by 32, and then we have x is equal to e to the negative w of the negative ln of 2 divided by 32. 3 solutions, you plug in those values, and I believe I did read the solutions before, but I forgot, but one of these two numbers that approximates to 1.02 and the other one is 0.97. One of those two, I'll actually, list those numbers down, the approximate numbers. And with that, there we have it. 3 solutions, plug it in, and then we actually get its equivalent to the following. So yeah, that's pretty cool if you ask me.